Welcome to computer science class. In the last class, we discussed about the algorithm flowchart, algorithm and flowchart. So now discuss the process of the coding, testing, debugging, and documentation. Before that, just recall the problem solving steps. The solving steps are the first one, problem definition. First is the problem definition. Second one is problem analysis. Second one is the problem analysis. Then third one is the design. So under design, here we discuss about algorithm and flowchart. That is then we discuss algorithm and flowchart. Next, fourth step is the coding. Fourth step is the coding. Fifth one is the testing and debugging. Testing and debugging. Sixth one is the documentation. These are the steps in problem solving. So here problem definition is it is a well-defined English statement. Then problem analysis, here we analyze about input, output and additional requirements. Then in the design there is a two sub-steps, algorithm and flowchart. Algorithm is a step-by-step well-defined instructions to solve our problem. It is a step-by-step procedure or step-by-step well-defined instructions to solve our problem. Then flowchart is a diagrammatic representation. Of the algorithm. Here we use basic flowcharting diagrams. To construct a flowchart. So next one is coding. Here we discuss the process of coding. So here coding means we translate the algorithmic step. So algorithm have a step-by-step instructions. Here in the coding, we translate the algorithm steps to programming instructions. It is a process. To translate. It is a process to translate algorithm steps to programming instructions. Here the steps are the set of instructions. Steps are the instructions. So coding is a process. It is a process to translate algorithm steps to programming instructions. So to write a programming instructions, we use any high-level programming languages. So to write a programming instructions, we use any high-level languages. So here high-level languages are C, C++, Java, JavaScript, like this. So we use any high-level language to translate a algorithmic steps. This process is called coding. So after coding, we have to test and debug the program. So after coding, we have to test and debug the program. So here testing is a verification. Testing is a verification of the program. So what is testing? Here testing is a verification of the program. Here verify the program about the correctness. Say each program works properly. Say for the verification, we substitute the sample data. So what it is? Here testing is a verification of the program. For verification, we input the sample data and verify it works correctly. Next one is debugging. 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 So here bugs. Here bugs are the errors. Bugs are the errors. Errors are called bugs in a program. Say errors are occur because say we have to write the programming instruction by using high level language. Then compiler. Compiler. Already we know that what is compiler. So compiler is a translator. It translates high level language to machine level language. High level language to machine level language because computer only understood the machine level language. So compiler is a translator. It is a system software. It translates high level language to machine level language. Here we write the programming instructions. Programming instructions. Say after writing the algorithm, we write the programming instructions. These programming instructions are written by using high level language. Those are not understood by the computer. So compiler translates these high level language to machine level language. While translating the high level language to machine level language, some errors are occurs. Those errors are called bugs. The errors in the programs are called bugs. Here the word debugging. Here the word debugging means detecting and correcting an errors. Detecting and correcting an errors. That is called debugging. Bugs are the error. Detecting and correcting the errors is called debugging. So here debugging. Here debugging is a process. It is a process to detect and correct. Detect and correct the errors. Detect and correct the errors. That is called debugging. So bugs are the errors. The process to detect and correcting those errors are called debugging. That is the fifth stage in problem solving. What we discussed, say coding. It is a process to translate algorithmic steps or algorithmic instructions to programming instructions because the algorithms and flowcharts are the machine independent. Algorithm and flowchart are the machine independent. We have to write algorithm and flowchart using paper and pen. But the computer needs a programming instructions. So we have to translate algorithms to programming instructions by using high level language. That is we call it as coding. After coding, after we construct a program or application package, then we have to verify that. Say the verification stage is called testing. Say how to test? By substituting the sample data, we have to verify the program whether it is works or not. Say compiler translates high level language to machine level language. We have to write a programming instruction in high level language. So compiler is a system software. It translates high level language to machine level language. While translating, say it occurs some errors. Sometimes it occurs errors. Those errors are called bugs. That is the programming errors. Programming errors are called bugs. Then detecting and correcting the errors. Detecting and correcting the errors. Programming errors. The process is called debugging. So after testing and debugging, we have to hand over our program to user. Say while handovering to the users, we have to maintain the manuals. Those manuals are called documentation. Say here documentations are the manuals. It is in the form of text. So those are called the documentation. So in the documentation, there is a two types. In the documentation, there is a two types. The first one is internal documentation. Internal documentation. Second one is external. Internal documentation. Then second one is external. These internal documentation are available with programming instruction. These are available with programming instructions. Because internal documentation, internal manuals explains about the variables, name variables. These are available through programming instructions. The external documentation again have user manual. Again have user manual. Then administrative manual. User manual, administrative manual. Then third one is developer manual. The external documentation have the textual representation. It is a textual representation. So external documentation have the manuals. So there is a three types of manuals. The first one is user manual. Second one is the administrative manual. Third one is the developer manual. Here, the user manual have the instruction about the program, how to handle, Then, administrative manual have the instruction how to maintain the program. It have the instruction about how to maintain the program. Then, developer manuals have overall flowchart algorithm about the program. It have all overall algorithm and flowchart about the program. It helps to further develop the program. So these are the three types of external documentation. Here there is a two types of documentations. First one is internal documentation and second one is external documentation. The internal documentation directly available with the programming instructions. But the external documentation is a manual. It is a manual. There is a three types of manual: user manual, administrative manual. The third one is developer manual. So the user manual have the user instructions how to use the program. It has an instruction about how to use the program. Then administrative. Say these administrative manual have the instruction about how to maintain the program. But the developer manual have overall structure of the program. That is, it have algorithm, then flowcharts, then instruction about how to develop the program. Those are available in the developer manual. These are the three types of external documentations. Let's discuss programming constructs. So here, constructs are the statements in a program. Constructs are the statements. In a program. Constructs are the statements in a program. Then constructs are also called basic building blocks of the program. These are the basic building blocks of the program. There is a three types of programming constructs. They are there is a three types of programming constructs. The first one is sequential programming construct. Then second one is selective. Then third one is iterative. Or repetitive programming construct. So here constructs are the statements. These are the statements in a program. So then also the constructs are called basic building blocks of the program. There is a three types of programming constructs. The first one is sequential programming construct. Second one is selective programming construct. Then third one is iterative or repetitive programming constructs. These are the three basic programming constructs. Say, let's discuss one by one. Say, consider the first one, sequential programming construct. So in a sequential programming construct, all instructions are execute one after the another. All statements are execute one after the other. See, program have a set of instructions. Program have a set of instructions. Those instructions are also called statement. Those instructions or statements execute one after the other. That is called sequential programming instructions. That is, all instructions are statements. All instructions or statements execute one after the other. One after the other. One after the other. One by one. That is called sequential programming instructions. Say for example, S1 is a statement, S2 is also one of the statement, S3 is also one of the statement. Then program have n number of statements. Then all statements are executed one after the other. So assume that S1, S2, S3 and Sn stand for the statements. So then in sequential, all statements are executed one after the another. First the statement 1 is executed, after that statement 2 is executed, after that statement 3 is executed, so on up to the last statement is executed. There is no forward execution, then there is no backward execution in sequence of statement, in a sequential execution. Here statement 1, 2, 3 are the statement 1, 2, 3 goes up to n are the, it may be input statement, it may be input statement, or it may be output statement. Either S1, S2, S3 are the input statements, or it may be output statement, or an assignment statement. Or an assignment statement. See, in a sequential programming construct, here it is a sequential programming construct. In a sequential programming construct, all statements are executed one after the other. There is no backward execution, there is no forward execution. Say in this diagram, S1, S2, S3, Sn are the statements. See the flow direction. Say one after another, the statements are executed. Where the statements are the input statement or output statement or an assignment statement. So here the example for the input is, here the example for the input statement is, in an algorithm we write say input A comma B, then input radius or input P T R. So these are the example for input statement. These types of statements are written in a S1, S2, S3 statements. Then the second one is output. In an algorithm, we also write output S, then output circumference. So like this we have to write these statements. These are the output statement. These types of statements are written in a sequential programming instructions. Then there is a assignment statement. The example for the assignment is, say we write simple interest which is equal to P into T into R all divided by 100. It is an assignment statement. Then C back arrow of A plus B, it is an assignment statement. Area, that is 3.142 into R into R. So these are the assignment statements. These types of statements are written in a place of S1, S2, S3. That is the sequential programming construct. All statements are executed one by one. The statements are either input statement, say like this, say input of AB, input of R, input of PTR. Then it may be output statement. Already we write in an algorithm. The output statements are output S, output circumference, say output area, output simple interest. So those are the example for the output statement. Or an assignment statement. The example for the assignment statement is, say assign PTR by 100, C equals A plus B, then area 3.142 into R into R. So these are the assignment statement. Say already we write the algorithm to find the sum of two numbers, to find the simple interest, to find the area of a circumference, to find the area of a circle. These are all examples for the sequential programming instructions. Say in all those algorithms, the statements are executed one after the another. So those algorithms are the example for sequential programming instructions. Okay, let's discuss the second construct, that is selective construct or selection construct. Second one, selective construct or selection construct. This is also known as decision construct. This is also known as decision construct. This is used to take a appropriate decision. It is used to take a appropriate decision. The selective constructs are used to take a appropriate decision. There is a 5 types of selective constructs. There is a 5 types of selective constructs. The first one is simple if. Simple if. Second one is if else. Second one is if else. Third one is nested if. Third one is nested if. Fourth one is if else if. Fourth one is if else if. Then last one is multiple selective. Multiple selective. So these are the different types of selective constructs. So selective constructs are used to take a decision. These are helps to take a appropriate decision. Then these decisions are depends on the condition. These decisions are depends on the condition. So there is a 5 types of selective constructs. The first one is simple if. Second one is if else. Third one is nested if. Fourth one is if else if. Then fifth one is multiple selective. Say here we discuss all the types in detail. So consider the first one, simple if. Simple if. It is also called one-way branching statement. It is also called one-way branching statement. It is a one-way branching statement or one-way branching construct. So here we take a decision. Here we take a decision whether the statement is executed or not. Whether the statement is executed or not. Here we take a decision. Here we take a decision about this statement, about the statement whether statement is executed or not. Whether the statement is executed or not. So hence it is a one-way branching statement. Hence it is a one-way branching statement. There is a two alternatives. There is a two alternatives. Among those alternatives, only one statement is selected. Say in a program, there is difficult to write all the programming sequential instructions. There is a difficulty to write all the programs in sequential instructions. Sometimes we have to take a jump to the another statement, or we have to forward to the another statement or another set of statements. Hence, we take a help of selective construct, because the selective constructs are used to take a appropriate decision. To take a appropriate decision, we have to use any one of the selective construct. Say all selective construct, all these types of selective construct can perform different operations. Among this, simple if have a one-way branching statement. It works as a one-way branching statement. So what is the meaning of one-way branching? Here you have to take a decision about this statement. Program have a sequence of instructions. Those instructions are called statement. You have to take a decision about the statement whether the statement is executed or not. So that is the simple if. Just follow the syntax. How it works. So here syntax are the predefined rules. These are the predefined rules. So these syntax are used in the programming instructions. So how to write the simple if? Simple if, that is the syntax. It begins with if. So either we write in uppercase or lowercase, but in an algorithmic manner we have to write in an uppercase. Say if followed by condition. So followed by the condition. So here we write as either test condition or normally write it as condition. Then statement. Then and if. So here the simple if. So verify the test condition. Here test condition returns either true or false. Test condition returns either true or false. If it is true, the succeeding statements are executed. Otherwise, these statements are not executed. That is the meaning of. So we have to take a decision about this statement whether the statement is executed or not. So follow the flow chart. Say the flow chart. Say first we have to take a decision. So that is the condition. The romance is used to represent a condition. Inside that here we write is condition. Either we write test condition or condition. Then there is a question mark. If it is true, this stands for true. Statement is executed. Say following statement is executed. Say if it is false, F stands for false. If it is false, next statements are executed. That is the working principle of simple if. See the flow direction. So in a simple if, so it begins with a if, then followed by condition or test condition. It is a relational expression. Either it returns true or false. If it is true, succeeding statement is executed. That is, statement is executed. If it is false, statement is not executed. See the flow chart. Verify the condition. There is a question mark. Say have two alternatives, either true or false. If it is true, then statement is executed. If it is false, the statement is not executed. So see the false. So if it is false means these block of statements are not executed. Directly execute the next sequence of statements. Here we take a appropriate jump based on the condition. That is the working principle of simple if. Okay, let's write an algorithm and flowchart to demonstrate the working principle of simple if. This algorithm demonstrates how the simple if works. So write a program or write an algorithm. Write a algorithm and flowchart. To find biggest among two numbers. So already we write a program to find biggest among two numbers. Those we use if else, but here we write the same program using simple if. Say first we write a algorithm. So algorithm shall begin with step number 1, that is the beginning. stop. Stop. Then in this step 2, so the problem definition is to find biggest among two numbers. So inputs are 2. So input, so that is read two numbers. Read two numbers. The process is input two numbers. Here two numbers are A, B. Then this step 3, use the temporary variable assign a number. Assign a number. So use the temporary variable big back arrow of A. So that is among two numbers. First we have to assume that first number is the biggest number. Say our assumption is wrong. When it is wrong, say B is greater than A. If B is greater than A, then our assumption is wrong. Again, we have to conclude that the B is the biggest. Before that, among two numbers, assume that the biggest is the first number is the biggest number. Then compare. In this step 4, compare. So how to compare? If our assumption is big, it is less than second value then. When it becomes less than second value, so less than the second value, then we have to say that the biggest number is the big. So first we assume that first number is the biggest. That is A is less than B. A is less than B. Then which one is the biggest? Second one is the biggest. We assign big back arrow B. If this condition is true, succeeding statement is executed. Big is less than B. For example, A value is 5, B value is 6. So our big value, here we assign big is equal to A. That is A value is 5, assigned to B. Then B value is also 5. So here we compare big is less than B. What is the value of big? 5 is less than 6. Say big is equal to A value is 5 is assigned to big. So if 5 is assigned to big, so the value of the big is 5. Then here we compare. If big is less than B, 5 is less than 6. Condition is true. We have to reassign our assumption. That is the big value is the big. If 5 is less than 6, so 6 is the biggest value. We reassign big back arrow of 6. So value of the big is 6. Then and if close the and simple if. Then in this step 5, display A, B, or display two numbers. Output. So display biggest number. So biggest number is output big. Biggest number is big. So then end of algorithm. So step 6, end of algorithm. So stop. Carefully trace the program. What we done here? Just trace the program. We start the program. After that, we input AB. There is a two numbers AB. This is one memory location. This is also one memory location. Instead, both those two AB numbers are big and big. Then say input AB. So here we read the value 5. Here we read the value 6. Then assign a number. In step 3, we have to assign a big to the number. So here we assign big because A value is assigned to B. Back this assignment. A value is assigned to B. So A value is assigned to B. That is 5. Then compare. After that, in step 4, we have to compare big less than B. Big less than B. What is the value of big? So here it is 5 less than b value is 6. If it is true, then the succeeding statement is executed in a simple if. Verify the condition. Condition have two alternatives, either true or false. If it is true, succeeding statement is executed. Otherwise, the succeeding statement is not executed. Here, 5 is less than 6. Condition is true. If condition is true means we have to assign big equals b. Big equals b. Instead of 5, here we assign the b value, that is 6. So finally, we display the big value. The value present in the big is 6. So close the program. The biggest among two number is 6. Otherwise, take another example. Here a value is 15, b value is 10. A value is 15, b value is 10. Here we input ab. Then assume big is equal to a. Say value of 15 is the a. Okay, so A. Then compare big is less than b. Big is less than b. Say what is the value of b? Here it is 15 less than b value 10. 15 less than 10. Compare big is less than b. 15 is less than 10. Condition is false. 15 is not less than 10. Condition is false. Say in a if statement, if condition is false, succeeding statement is not evaluated. Succeeding statement is not evaluated. This statement is not evaluated. Then we come to the next statement. So in the next statement, directly output big value of the value bigger. That is 50. Say we trace the program using sample data. Okay. Let's write the flowchart for the algorithm to find biggest among two numbers using simple if. So see the first step. The first step is the star. To represent the star, write the over. See the second step is input AB. So input and output are represented with parallelogram. So write the parallelogram in the right input A, B. After that, here we assign a number. That is big back arrow of A. The assignment is a process. So write a rectangle in that big back arrow A. Here we assign A value to B. Next, we take a decision. For decision, write the rhombus. Write the rhombus. Inside that, write down is big value less than b question mark. We should have two alternatives. One is true, another one is false. We should have two alternatives. Say if big value is less than b, our assumption is wrong. So we have to reassign our assumption by assigning the b value. So big back arrow b. First we have to thought that first number is the biggest value. If biggest value is less than second value, less than the second value or b value, then our assumption is wrong. So reassign our assumption by change the value of big. So here we assign the value of big b to big. So if it is false, so we have to execute the next statement. Here next statement is the output big. So output means again like the parallelogram. So in that output b, because the variable big holds the biggest value. So finally end of algorithm. So again write the oval, right stop. Then mention the flow direction. It is an example for simple if construct. The selective statements are used to take a decision. See that here we take a decision. Then based on the condition value we have to take a decision. In a simple if, it is a one-way branching statement. It is a one-way branching because here there is only one statement here. This statement is executes depending on the decision either true or false. If it is true, statement is executed. If it is false, this statement or this block of statements not execute. That is the working principle of simple if.